Welcome to AP Psychology Research Methods Week 2. This week we're studying the scientific method and all the scientific foundation of AP Psych. So let's get started. So as we talked about last week, how AP Psychology is going to be a blending of both science and philosophy. So when we start with the science, we have to start with the scientific method. Now you've studied the scientific method since you were probably in grade school. It's a system of gathering data so that bias and error in measurement are reduced. It's all about the research experiment. So the steps in the scientific method: come up with a question, form a hypothesis, test the hypothesis, draw your conclusion, and report your results. This is the foundation of every experiment. You've done this many times, so we're not going to belabor the point. Now, when we talk about psychology, we have to talk about it in different formats. Now, naturalistic observation is watching animals or humans behave in their normal environment. The most famous person who has conducted this experiment is Jane Goodall. She has studied gorillas in the wild for many, many years, and she reported back about how they behaved and all that. Now, major advantage is you get a realistic picture of the behavior. So for instance, if I wanted to go figure out what high schoolers talk about at lunch, what I would do is I would dress up like a student and I would go and I would sit down at a table near high schoolers and just listen. I wouldn't announce that I'm there listening to their conversation. I would just go and listen. That is naturalistic observation. I don't declare myself as being there, and I'm just sitting there taking in the information. Now, there are different disadvantages to it. Observer effect. What that means is the tendency of people or animals to behave differently than normal when they know they're being observed. Okay, if I told you I'm listening to your conversations, are you going to have the same conversations you would if I wasn't there? Probably not. Participant observation is a naturalistic observation in which the observer becomes a participant in the group and being observed to reduce observer effect. What that means is if I wanted to figure out what high schoolers talk about on a regular basis, I would become good friends with a bunch of high schoolers and have continual conversations. So the first conversations we have are going to be kind of forced and not really genuine, but maybe within a couple months we can actually start having some real conversations. That would be participant observation. Observer bias is a huge part of psychology, and we try to eliminate that or minimize it to the best of our abilities. It's a tendency for observers to see what they want, what they expect to see. So if I think high schoolers only talk about clothes and cars, when I'm sitting there listening to conversations, those would be the only things I really recall and remember: cars and clothing. Now, blind observers are people who do not know what the research question is, and those people have no idea why we're there. Those are people who go out and try to observe, but they have no idea what we're focusing on. And you have to keep in mind, when you do naturalistic observations, each one is a little bit different and is unique. So it's very difficult to have. So now, Jane Goodall, like I said, is the quintessential example, and you can see pictures of her. She spent like 19 or 20 years in the jungle learning about the gorillas. She travels around the world, very, very famous. Now, just another type of descriptive method of research is laboratory observation. When you typically think of experiments, you typically think of laboratory. It's watching animals or humans behave in a laboratory setting. So there's a guy in a white coat conducting the experiment, and you're doing whatever you're supposed to be doing. Now, the great things about doing research in a laboratory, it's very controlled. Everything is controlled by the experimenter. The air temperature, the room lighting, the amount of information you get, the clothes they're wearing, everything is dictated, and it allows for specialized equipment, which means I can bring in, as the experimenter, anything I want into the room and can manipulate it that way. So there are some disadvantages to it. Now, disadvantages, it is an artificial situation. Unlike naturalistic observation, if I'm going to see what you guys talk about, I'm at least in a normal setting that you'd be in. If I brought in high schoolers to talk in a lab setting, it's not a normal situation that you sit and have a conversation with your girlfriends with, so it's going to be kind of forced. It also could lead to the formation of a testable hypothesis. And that's the whole big key. Now, when we talk about another descriptive method is called a case study, and it's a study of one individual in great detail. Now, the great thing about case studies is that it allows us to analyze information in a much deeper and much more fulfilled way. We focus on one person or two or three, but that's it. And we are very, very in depth. Now, the disadvantage is that there's not direct correlations. If I study why you are successful in AP Psych, it doesn't mean there's a direct correlation to other people who are successful in my class, but it does give me a better understanding of how a person can be more successful. Now, one of the most famous case studies is Phineas Gage, which we'll be meeting here in a couple of weeks. So there are three major types: case study, experiment, and naturalistic observation. And then finally, we have surveys, which are the most popular way. And this is when researchers will ask a series of questions about the topic under study. You've all filled out surveys 1,000 times, and it gives us a representative sample. It's a random selected sample of subjects from a larger population. So if I wanted to ask 10th graders at Plant High School, I would ask only sophomores. I would not include the juniors and the seniors. If I wanted to ask the female population of Plant High School, I would ask all the girls, not the boys, those types of things. Now, when we talk about representative samples, we have to talk about population. Now, the population is the entire group of people or animals in which the researcher is interested in. My experiment earlier about trying to figure out what high schoolers talk about would be, my population would be high schoolers. Now, when we talk about surveys, which we've all seen 1,000 times, this is not anything new, is the major advantages is that you can collect data from large numbers of people, and it does give you a ton of information to pull from and able to study. It also allows you to study covert behaviors. By the wording of the survey, you can test many different things, and you can see biases, you can see laziness, all those different types of things. Now, the disadvantages to surveys, you have to ensure a representative sample, which means if I'm testing high schoolers, but I test only seniors, it's not a real population of a high school. That's only a slight population. Now, once we do all this research, we have to find relationships, and relationships are called correlations in psychology. Now, a correlation is a measure of the relationship between two variables. Now, what is a variable? It is anything that can vary or change. So anything that we are looking at that changes in an experiment is considered a variable. So when we measure if the two variables go into a mathematical formula or produce a correlational coefficient, which represents do they have a direct relationship and the strength of that relationship. When we talk about research, we have to know if there's a cause-effect relationship, and that's what correlations are. Do one thing cause another thing to occur? If it does or if it doesn't. Now, knowing if one variable allows researchers to predict the value of the other variable. Okay? Now, finding relationships. Now, correlational coefficient vary from -1 to +1. Now, the closer to 1 or -1 means the stronger the relationship is. If there's no correlation or absolutely zero relationship, like for instance, the amount of pizza you eat tells us how high your grades are. Well, darling, I could eat a lot of pizza. My grades would not be A's if I ate a lot of pizza. There's no relationship there. However, the more time you study, the higher your grades are. There is a relationship there. That would have a positive 1-to-1 ratio correlation, while how much pizza you ate to your grades would have a zero correlation. Now, a positive correlation, variables are related in the same direction. As one increases, the other one increases. So the more you study, the higher your grades get. And the other negative correlation are related in the opposite direction. As one increases, the other decreases. So the amount of time you study means the less amount of sleep you have would be an example of a negative correlation. So a positive correlation, the more you study, the higher your grades. A negative correlation, the more you study, the less sleep you have. Now, when we talk about correlation, it does not prove causation. That is a huge thing. Just because one thing happens, like as your grade, the more you study, your grades go up, does not mean by studying causes grades to go up. We all know that there's some smart kids out there who don't really have to study and still do incredibly well. So correlation does not mean causation. Now here are some scatter plots for you that's showing all the directions. Now if you look at The first one right here, which is a straight line, it's a perfect positive correlation. That means that there is definite causation there, but not there's definitely correlation there, but not causation. Now, over here is our modest positive correlation, with the trend of going up to down is going to show us that there is some sort of relationship there. Our next one over is the one with all the scattered. This shows us that absolutely nothing is guaranteed and there's no predictive pattern, and as you can see on the bottom. Now, the experiment. Now, an experiment is something you've heard, seen of, dealt with many, many times, and we'll be seeing a lot of them in psychology. And so we need to be refreshed and make sure we know exactly what they are. Now, experiment is a deliberate manipulation of a variable to see if corresponding changes in behavior result. So what happens is the experiment manipulates one thing to see if there is a reaction or a change in behavior. Now, the operational definition of an experiment is the definition of a variable of interest that allows it to be directly measured. Your operational definition is really the rules of the experiment, how to set up the experiment, how to do it, what things are being compensated for, what things are not being compensated for. Now, in your experiment, you have an independent variable and a dependent variable. The independent variable is being manipulated by the experimenter, while the dependent variable is the one that the subjects are responding, is their response or behavior to the independent variable. So say for instance, I had a basket of candy by the door. Okay, on your way out, you decide to steal a piece of candy from my jar. Okay, now that is my experiment, is the candy by the door. My operational definition is what type of candy I'm going to put in there. Am I going to put chocolate, or am I going to put like Necco wafers, which no one likes? Okay, now your operational definition would say how many pieces of candy in there. Is it a lot? Is it a little? If there's a lot of candy, more people are going to steal it because it's harder to tell if someone stole it. If there's only one piece of candy, most people aren't going to steal it because no one wants to steal the last piece. Okay, so operational definition are all the rules for that type of candy. Now, the independent variable of this experiment would be my candy. I put it there. I'm the experimenter. I put the candy by the door. The dependent variable is whether you, as my subject, whether you steal the candy or not. So putting candy by the door is my independent variable. Whether you steal the candy or not is my dependent variable. And my operational definition is going to tell us what type of candy, how much candy, all of those different types of rules for it. Now, when we talk about experiments, we have to talk about experimental group. Okay, they are the subjects in experiment who are subjected to the independent variable. So my experimental group would be my AP Psychology classes. My control group are the subjects in the experiment who are not subjected to the independent variable and who may receive a placebo treatment. I'm going to do a little experiment with you guys in class, and this will help kind of clarify this for you easily. Now, when you think about your random assignment, it's about making sure that you're not controlling who's in what group. It's assigning subjects to an experimental or control groups randomly, so you're trying to eliminate as much bias. You don't want to put all the smart kids in the control group and have all the dumb kids in the experimental group. You want it to be as fair as possible. Now, when we talk about experiments, there is a major component called the placebo group. The placebo effect. Now, this is the phenomenon in which expectations of the participants can affect. So, for instance, if I was giving you a weight loss drug and I gave you the drug and it's really a placebo or a sugar pill, and you're taking the pill, and I'm saying, and before you start taking it, I'm telling you, you're going to lose like 20 pounds. It's going to be amazing. So, anyway, you start taking the pill, and once you start taking the pill, all of a sudden you start losing weight and you're so excited, everything's wonderful, and then I tell you later it's a sugar pill. You've tricked yourself into thinking that you're losing weight, so you've actually started losing weight. You watch what you're eating, you watch your diet, all of those different types of things are going to help you lose weight with absolutely no support from any type of drug. Now, a single blind study with the placebo effect, subjects don't know if they're in the experimental or the control group. So if I was doing that drug test, the experimental group would be actually receiving the fat loss and the weight loss drug, while the control group is not. Now, the reason why we have a control group and experimental group is so we can directly compare. If the people in the experimental group lose 10 pounds, but my control group loses 9 pounds, is that drug really that effective? No. People who weren't on the drug lost 1 pound less. I mean, that's not that impressive. However, if my experimental group loses 20 pounds and my control group, who did not receive the drug, only lost 3 pounds, is that impressive? Yes, absolutely. It allows us to directly compare with one another. Now, in a single blind study, the control group does not know that they're in the control group, and the experimental group does not know. So everyone thinks they're all getting the drug. So half of the participants think they're getting the drug, and the other half is actually getting the drug. Now, with the experimenter effect, this is the tendency of experimenters' expectations for a study to unintentionally influence the results. Now think about it. For this weight loss drug test, if I was the creator of the drug and I'm giving out this drug test, am I going to be nicer to the control group or the experimental group? The control group I need to be able to compare, but the experimental group is what's going to pay me millions of dollars. If my experimental group works out and I solve how to lose weight fast, I'm going to be a billionaire. So if I know this as the experimenter, I will be nicer to them, I will have more bias towards them, and I will do whatever they want. Is that fair? No, absolutely not. Okay, so what we try to do, and the best way to eliminate bias, is to have a double-blind study. So a single-blind study means the participants don't know. Double-blind study means neither the experimenter nor the subjects know who is in the experimental group and who is in the control group. That way there is no balance for anyone, no bias for anyone. And it reduces placebo effect and experimenter effect. So no one is overwhelmingly favored. Now, quasi-experimental designs, they're not considered true experiments because the inability to randomly assign participants to the experimental and control groups, for example, if age is a variable of interest. For instance, if I do an experiment in my classroom, is it really a experimental test? No, it's not, because I'm not doing it on a large random assignment. All of you are stuck with me for the whole year, so it's not really a random assignment. That's what quasi-experimental designs are. Now, example of real experiments, a hypothesis is an external reward would reduce creativity. Okay, so external reward would reduce. The independent variable is 2 sets of instructions. Dependent is creativity on our project is judged by raters blind to the group. Okay, so this is just an example of an experiment for you. Now, your experimental group is instructed to make project to complete for an award, prizes, and your control group is instructed to make project for fun. Prizes will be raffled off. Okay? Results support hypothesis. Those competed for extrinsic reward were less creative. So the people who were not giving a reward, who were doing it for themselves, were more creative, while those who were not doing it were less creative. Okay? So ethics, we can't do whatever we want. I can't test you on whatever I want. I cannot manipulate you. In psychology, we have an ethics committee, and they look over proposed research study and judge it according to its safety. We can't do whatever we want. We can't just go around cutting off people's hands just to see how people adapt. We can't ruin children's lives by doing scary experiments on them. We have to be fair. Now, here are your ethical guidelines. The rights and well-being of participants must be weighed against the study's value to science. Participants must be allowed to make informed decisions. Deception must be justified. I am allowed to lie with you as long as it makes sense. I can't lie to you and you hurt yourself. That's wrong. I can lie to you in order to get you to react in a very safe way, and then I can inform you. Participants may withdraw from the study at any time. I cannot force anyone to stay. Participants must be protected from risks and told explicitly of risks. I have to debrief. If I do an experiment, I have to debrief, and data must remain confidential. I'm not allowed to tell your name because it hinders my ability to conduct science for it. Now, some of the major ethical conflicts we have in psychological research is animal research. The reason why we do conduct animal research is because it answers questions we could never do with human research. Drug testing, for instance. We do a lot of drug testing on animals because, I mean, believe me, I see both sides. It's better to hurt a rat than it is a human, and I hope we can all agree to that. So if this drug can save lives, it's better to hurt a rat in the process than kill, 500 humans, of course. When we do animal research, it is to focus on avoiding exposing them to unnecessary pain or suffering. We're not allowed to do whatever we want to them, but we are allowed to conduct research on them. And we only use it about 7% of psychological studies. If you are going to do animal research, it is a whole other level. Now, to conduct any real research, it's a pretty rigorous process to get it approved. To do any type of animal research is a ton of paperwork and approval because of the concern for not harming animals and having unnecessary pain and suffering. Now, when we deal with animals, we deal with them in many different ways, but most of the time it's typically for drugs. Now, critical thinking, when we talk about experiments, is making reasoned judgments about claims. We're trying to figure out what's the best way to attack or answer a question. Now, there are 4 basic criteria. The very few truths that do not need to be subjected to testing. So most things should be tested. All evidence is not equal in quality. We have to figure out what is the best information and research in order to answer those questions. Just because someone is considered to be an authority or have lots of expertise does not make everything the person claims to be true. We have to have justified behavior, and critical thinking requires an open mind. Now, we do have pseudopsychologies, and these are the systems of explaining human behavior that are not based on consistent or scientific evidence. That's why they're called pseudopsychologies. They're not based on scientific evidence. We have phrenology, which is the reading bumps in the skull, palmistry, which is reading palms, and graphology, which is looking at handwriting. There's no real science behind them. However, they do have some types of truth, typically more insight, not truths, but they're not your typical research. All right, guys, well, that's the end of week 2. I hope you have a great week. This is the foundation of psychology. If you do not do well this week, it's going to be a rough year just because experiments are everywhere. I hope you have a great week. Thanks for watching, and don't forget to like.